So let's look at thermochemistry, and the first thing we want to look at is how to manipulate thermochemical equations. So let me write here one for you. So this is hydrogen gas plus oxygen gas giving us water as in liquid. Delta H is equal to minus 572 kilojoules. Now a few things to know over here. First of all, that the equation is balanced, so which means that you have 2 moles of hydrogen, 1 mole of oxygen giving us 2 moles of water, and everything balances out. That's the important part of any thermochemical equation. The other thing that we can tell from this equation is that delta H is negative, which means that this is exothermic reaction. Okay, if it was endothermic, it would be positive. So this is exothermic reaction, which means energy is being released. So one can take any of these equations and you can manipulate them, which means, for example, if we say that we want to reverse the equation. So if you want to reverse the equation, that means you have 2H2O liquid going to 2H2 hydrogen and gas. Take a little time to write the gas and all of this, because delta H enthalpy is actually a state function, so each state becomes really important. So in this case what we did is we reversed the equation. So now water is our starting material, a reactant, instead of the product. So then because the equation is reversed, then delta H also is reversed, okay, which means that before it was exothermic, now it becomes endothermic. So 572, the value does not change, only the sign changes. Okay, so now this is endothermic reaction. So very simple. Okay, so when you reverse the equation, you reverse the sign also. So endo becomes exo, exo becomes endo. Second thing, if you half the equation, okay, so which means that you only take half the equation. So in half the equation, which means that you have hydrogen gas plus half O2 gas to give 1 molecule of water. Now only in thermochemical equations and maybe one other place you might see half as coefficients, otherwise usually we don't use them for balancing equations. We use whole numbers for most of the time. So now in this case delta H, the sign is still the same because hydrogen is still the reactant, okay, and so the sign remains the same. So we still have minus 572, except that now because we have half the equation, we also need to divide the delta H value by 2, so that also becomes half, and so now this is minus 286 kilojoules. All right, so very simple manipulation. If I had 1/3 of the equation, I would be dividing that by 3. Okay, and then a third manipulation is to double the equation. Again, double, triple, however, whatever number you are increasing it by, that's how you will multiply. So let's do this. So now we have 4H2 gas plus 2O2 gas to give 4 water liquid. So delta H now still the same, minus 572 kilojoules, which means by same I mean that it's still exothermic, but now you're going to multiply this number by 2, and so your answer becomes minus 1144 kilojoules. Okay, so keep it simple. If you're doubling the equation, you double the delta H value, the enthalpy value. If you're dividing it by half, then divide the delta H value. So you manipulate accordingly. This is called manipulating of thermochemical equations. So let's just do one more example and then we'll go on from there. So let's take that we have carbon monoxide as a gas, nitrogen monoxide gas, carbon dioxide gas plus half N2. See again the half there. Yeah, we usually don't see those kind of things. And delta H value for this is minus 373 kilojoules. So calculate for 2 carbon dioxide gas plus N2 gas to give 2 carbon monoxide gas plus 2 NO gas. So when you're looking at this equation that you have to calculate for, the first thing you look for is the equation that's given and the equation that's required, and see if they're the same or are they inversed. So in this case, this is reversed. So equation is reversed from the given equation. And then what else? So you look at the coefficients, and carbon dioxide here is 2CO2. So if it is 2 carbon dioxide and here it was 1, it means that you have to multiply something by 2, which means the whole equation. So reverse and multiply by 2. So that's what the equation has been manipulated into, which means that the equation has been reversed and it has been multiplied by 2. So that's the same manipulation you're going to do for delta H, which was minus 373 to begin with. Now what you're going to do is delta H will be positive 373 and you will multiply it by 2. Okay, so that's how it works out. And so this should give you 746 kilojoules, and of course this is positive. Now if you write the positive, that's okay. If you don't write it, it's of course understood. I like to write the positive just because. So this is how you would manipulate thermochemical equation. It is quite simple, so just look at if it's reversed, if it's divided by 2, multiplied by 2, and that's how you deal with the enthalpy value as well.